Chapter 9, Database Services. Chapter 9 covers AWS database services, Amazon RDS, Amazon Aurora, DynamoDB, ElastiCache, DocumentDB, Neptune, QLDB, and TimeStream. The goal is to understand how AWS splits database choices by workload model, not just by product name. Database architecture starts with the shape of the data and the way the application uses it. Some workloads need relational transactions, joins, constraints, and SQL. Some need massive key value scale. Some need ultra-fast caching. Some need document models, graph relationships, immutable ledgers, or time series ingestion. AWS offers many database services because these access patterns are genuinely different. A senior architect should not ask, which database is best? The better question is, what data model, consistency model, latency profile, scale pattern, and operational model does this workload need? Amazon RDS is the managed relational database service. It supports familiar engines such as PostgreSQL, MySQL, MariaDB, Oracle, and SQL Server. RDS is often the right choice when the organization wants a standard relational database with less operational burden than self-managed EC2. It handles many routine tasks such as backups, patching, monitoring integration, multi-AZ options, and read replicas. RDS is a strong fit for traditional business systems, transactional applications, internal tools, and migration workloads where engine compatibility matters. Amazon Aurora is AWS's cloud-native relational database engine, compatible with MySQL and PostgreSQL. Aurora is designed for higher performance, better availability patterns, storage auto-scaling, fast failover, and deeper AWS integration than a traditional managed engine. In many new AWS native relational designs, Aurora is the first serious candidate because it gives SQL compatibility while using a distributed storage architecture underneath. Aurora is also where some of the most important modern relational patterns appear. Aurora Global Database supports multi-region read scaling and disaster recovery patterns, and newer active-active or multi-write patterns may matter for selected global transactional workloads. Zero ETL integrations also matter because they reduce the need to build fragile custom pipelines from operational databases into analytics or search systems. The practical lesson is that relational databases are no longer isolated islands. They increasingly participate directly in analytics, search, AI, and global availability designs. DynamoDB is AWS's flagship NoSQL database. It is a serverless key value and document database built for very high scale and low latency access. DynamoDB is a strong fit when the access patterns are known, queries are predictable, and the workload needs massive throughput without managing database servers. It is widely used for event-driven systems, user profiles, session data, metadata stores, high-volume APIs, and serverless architectures. The most important DynamoDB design skill is access pattern thinking. You do not model DynamoDB like a relational database. You design the table around how the application will read and write data. Partition keys, sort keys, secondary indexes, item size, hot partitions, conditional writes, streams, TTL, and global tables all matter. DynamoDB can scale extremely well, but only if the data model supports the access pattern. Global tables make DynamoDB important for multi-region systems. They allow data to be replicated across regions, so applications can operate closer to users and improve resilience. Newer consistency improvements make the global story more interesting for workloads that previously struggled with eventual cross-region behavior. But even with stronger platform capabilities, architects still need to think carefully about conflict handling, write patterns, latency, and business rules. ElastiCache is the caching layer. It supports Redis-compatible and Memcached-compatible workloads and is used to reduce latency, offload databases, store sessions, manage leaderboards, accelerate reads, and support real-time application behavior. A cache is not just a faster database. It is a performance and resilience tool that sits in front of slower or more expensive systems. Used well, it improves user experience and reduces pressure on the primary data store. ElastiCache Serverless reduces some of the old sizing burden by allowing capacity to scale more automatically. Caching has also become more capable, with search and vector-related patterns increasingly appearing in memory-first systems. Still, the core design question remains the same. What happens if the cache is empty, stale, overloaded, or unavailable? A senior engineer designs the cache as an acceleration layer, not as a hidden single point of failure. DocumentDB is AWS's managed document database compatible with MongoDB-style workloads. It fits applications that naturally store JSON-like documents and need flexible schemas. It may be relevant for content systems, catalogs, user documents, and applications migrating from MongoDB-compatible models. It should not be chosen just because flexible schema sounds easy. Document databases still need indexing discipline, query design, backup strategy, and operational awareness. Neptune is AWS's graph database. It is designed for highly connected data, where relationships are central to the workload. Examples include fraud detection, identity graphs, recommendation systems, knowledge graphs, network topology, and relationship-heavy analytics. A graph database becomes valuable when the question is not only, what is this record, but how is this thing connected to other things? QLDB, Quantum Ledger Database, is a managed ledger database. It is designed for immutable, transparent, cryptographically verifiable history. This fits workloads where the history of changes matters and where tamper-evident records are part of the requirement. It is not a general replacement for relational databases or blockchains. It is for ledger-style systems where auditability and a complete journal are central. TimeStream is AWS's time series database. It is built for data where time is the organizing dimension. Metrics, telemetry, IoT readings, operational events, application measurements, and monitoring-like workloads. Time series databases are optimized for high ingestion rates, time-based queries, retention, and downsampling patterns. TimeStream is relevant when the workload is dominated by time-indexed measurements rather than traditional entity relationships. A senior architect should also think about integration. Databases rarely stand alone. RDS and Aurora may integrate with Redshift, OpenSearch, Backups, Secrets Manager, KMS, CloudWatch, and IAM. DynamoDB can trigger streams and Lambda workflows. Elasticache often sits in front of relational or NoSQL databases. Neptune may support AI and knowledge graph scenarios. TimeStream may feed operational dashboards. The data layer is not only storage, it is part of the platform's reliability, security, analytics, and cost model. The bottom line is simple. Choose the database by workload shape. Use RDS or Aurora for relational systems. Use DynamoDB for high-scale key value and document access patterns. Use Elasticache when latency and load reduction matter. Use DocumentDB for MongoDB-compatible document workloads. Use Neptune for graph relationships. Use QLDB for immutable ledger history. Use TimeStream for time series data. The best database choice is not the most advanced one. It is the one that matches the data model, access pattern, consistency need, and operational reality.